Okay, so we've covered the design effects and everything. Now, what happens in surveys very often is that we ask people questions and then they answer. And as a result, there are all sorts of errors that can crop into this. We might not ask the right people and so on. And so far, we've just been talking about biases and imprecision caused by just sampling variability because we chose this sample instead of that sample, you know, and so on. So just chance. But there are other sources of error, and I want to cover 4 of them. One is called the selection bias. The other is the non-response bias, recall bias, and the last one is lying. Unfortunately, people lie, so we need to say something about that. So, okay, selection bias. Now, the classic example of selection bias is what happened, and it's happened repeatedly, but I've just chosen this one from 1936 because it made such a big difference, and also because it's topical right now, because what they did in 1936, the Literary Digest predicted the outcome of the presidential election of 1936, and they had Landon with 1.3 million to beat Roosevelt, who they predicted would only get 972,000 votes. And of course we know that they were wrong. Now, what happened, of course, because they were wrong, is that the Literary Digest actually went out of business. I mean, they'd had a good track record. They'd predicted from 1920 to 1932, they'd been right on the button in predicting who would win, and now all of a sudden they lost all credibility, and as I said, they went out of business. The problem is that this was quite predictable. You see, this was the Depression. Don't forget, this was the Depression, and who could afford to maybe pay for the stamp to return the card? You know, you had to be rich. You had to be Republican. And that's part of the problem. But the information was there because they asked each person who responded, they said, how did you vote in the previous election? And the greater majority who responded had voted for Hoover in the previous election. So this tells you what the flavor is of the sampling, that it wasn't a random sample. And this is exactly the problem we had with Ray Pearl when he looked at autopsy results. You know, who gets autopsied? Don't say dead people. You know, it's not everybody who dies has an equal chance of being autopsied. So the same idea here. So that's the selection bias. The non-response bias is also a very important bias. For example, you know, if you send out a survey, who responds to you? This is sometimes called the high school reunion effect. Who shows up at a high school reunion? Typically, it's the people who have been successful in life, and they want to show off to their high school friends. Here's another example of this. There was a survey done by Nancy Gatrell, and what she wanted to find out was how many psychiatrists sexually abuse their patients. Now, she didn't phrase it like that, but she sent out 5,574 questionnaires, and the response was responders of 1,442, and that's a generous estimate because it included 19 people who just wrote some cuss words on the response, and so a response rate of 26%. Now, of these 26% who responded, 7.1% of the males who responded said that they had had sexual relations with their patients, and 3.1% of the female psychiatrists who responded said that they had had sexual relationships with their patients. What about the non-responders? So the other 74%, do you think that maybe there was some relationship between doing something which is expressly prohibited in the Hippocratic Oath even? I mean, it goes back that far. do you think there might be some relationship between whether they responded or not and whether they had sexually abused their patients or not? So this is the issue. 26%, you say to me, oh, is 26% a bad response rate? And the answer is, it may be, it may not be. It depends how those 26% relate to those other 74%. Okay? If they're going to act the same way, then no big deal. You just have a smaller sample size. But if there's any reason to suspect that the non-responders are not going to act the same way as the responders, then you have a problem that you have to take care of. This distrust for surveys goes way back, and what I found here for you is a survey that was done by Benjamin Franklin, of all people. And what they wanted to do was determine whether this inoculation for smallpox, whether that had any effect or not. And there were the two camps. The one camp said, no, this is nonsense. It doesn't work, and you're putting us all at high risk, etc. And the other camp that said, no, it does work. So it was resolved by the magistrates of the town to cause a strict and impartial inquiry to be made by the constables of each ward. So they sent the constables out to do the survey. And now here's the result of the survey. And so what they did is they looked at here the group that got the smallpox the usual way, namely from somebody else who had the smallpox, and here's the group who had inoculation. And so of these, 9.3% died. Of these, only 1.4% died. So it looked pretty convincing about the impact of the inoculation. And we know that the constables took care of this data, so we can trust it. Here's another one having to do with lying. And this study was done of pregnant women. And what this had to do was looking at the outcome of the pregnancy and relating that to a drug intake. And the drugs they actually looked at was something like cocaine and marijuana and so on. But anyway, here are the results for cocaine. And what they did was they got all the right permissions, and they went through all the ethical standards and everything to have the mothers tested for cocaine. Every time they came in, they had them tested. In the antenatal visits, they had them tested for cocaine. Now, they also said to the mother, okay, yes, you did give us permission to test you, but we'd like to ask you tell us whether you've been using cocaine or not. Okay? So now what we have two sources of information. One from what the mother said, and the other from what the biological testing tells us. Then what they did is they classified the mother into one of three groups. And here they are. In group one, these were the mothers who didn't have drugs at all throughout the pregnancy. The second group were the mothers who, yes, were on drugs at the beginning of the pregnancy, but they stopped. Into the pregnancy, they stopped using the drugs. And then the last is, the other group is the group of mothers who just kept on using the drugs throughout the pregnancy. And they looked at these outcomes. They looked at birth weight, they looked at the length of the baby, they looked at head circumference, they looked at gestational age. And in every single one of these, what I've drawn here is the outcome from the biological testing. With every single one of these, you can see this downward slope between the drug-free, the first trimester users, and the cocaine users throughout the pregnancy. So in every single one of these 4 outcomes, there was a significant difference between the 3 groups. Yet, when they redid this analysis, but using the mother's response. Now the mother knew that she was going to be tested, so there really wasn't that much incentive to lie, except that maybe it's a face-to-face effect. I don't know. But anyway, when they redid this whole analysis, not using the biological testing classifications, but rather using the ones that the mothers said, the responses, none of these, the significance disappeared. So we got a qualitatively different result when comparing the two sources of information. So unfortunately, people do lie. It's sad. Now, I just ran across this just the other day. Be a man, it says, tell the truth. So what they did is they did a study, and it's just reported in PLOS One. They did a study of 91 men, and what they did is half the men got a shot of testosterone and the other half didn't, got a placebo. And then they made them roll a die, and then they paid them according to the outcome of the roll of the die, except nobody was watching. So what they did is they just asked them, what did you roll? Knowing full well that, you know, if they said the high, they would get that money. If they said low, they would get that money. Okay? So definitely there was incentive to lie, plus nobody knew what the real outcome was. And here are the results. And so here are the people with the testosterone, and they did it 0 to 5, but it's really the face that's showing is just add 1 to this. So this would be the face of 6, okay? And now what you'd expect is if it's just purely random, you'd expect about, the frequency would be about 16%, 1/6. So you'd expect something like here is what you'd expect. So there is a little bit too much here in the testosterone who would lie to get that extra money. Whereas with the placebo group, look at that. So they conclude from this that you know, it's not. In fact, that there's there it is. There's the title: Testosterone administration reduces lying in men. Now, of course, I'm a statistician, and what I did was I took these percentages, which they found highly significant in some cases. They did a little bit of statisticulation, I think. You know, they would say, okay, treat this as a binomial, then treat this as a binomial, and so on. Instead of that, what I did was I calculated the numbers and treated it as a 2/6 contingency table. And there's the command I put into Stata. And there you see it. There are the percentages they reported. But here are the actual numbers. And you can see there's 46 in the one group, 45 in the other group. And what you see is that the p-value is 0.136. So it doesn't look like there's any difference there. So I don't know. Maybe I've done something wrong. I don't know. But it doesn't look like so. It doesn't look like you can blame it on testosterone, or you know that you can say anything about that from this exercise. But anyway, I thought it was fun.